of this for this computation. And so really, computation will just end up being this is counting outcomes. So we're really setting up the classical view of probability, that there are things that are equally likely to happen, like rolling the dice, flipping a coin, drawing a card. But there's another view of statistics, and there's sort of like the Bayesian view, and it really depends on what you think probability is. Right now, since we're in this class, we're thinking that it's the classical view, but we'll get to a little bit more of that later. All right, what I want you to do is take out all possible ways that you can write down the 3 letters of MAT. Okay, so write just the list. So you could have MAT, ATM. How many ways could you write out those letters? Why are you so slow? Okay, now write out all the letters. I don't like you. Now I want you to write all the ways you could write the letters of ABBA. The B. The first one, you should have gotten 6 different ways to spell the letters of math, right? What's one way you could describe why that is so? Yeah, Shane?
You could do it, think of it in terms of like a factorial.
Sure. So how many choices do I have for the first letter?
3.
And once I've used that up, how many choices do I have for the second letter?
2.
And the third letter?
1.
Okay, so there's 6 ways that I could decide to do that. Now let's take a look at Abba. Actually, I should think of Abba as father, as in the Bible, much more pleasant experience. All right, now suppose that it was A, B, C, D. How many ways could I do for A, B, C, D by similar reasoning? 4 times 3 times 2 times 1, which is 4, or 24. So now let's think about Abba. how many ways are there to arrange the letters of A's? If I've got an A and an A, like suppose I had A1, A2, and then I had a B, or blue A, and then the two B's. How many ways can I arrange these two letters? You have the blue first, the red first. So really I should divide by 2 factorial, right? And what about the two B's? Divide by how much? 2 factorial. And so I should get 24 divided by 4, or 6. Did you get 6?
So the 2 factorial is because there are 2 of the same kind?
And there would be 2 ways to arrange it if I had them all listed out. So let's suppose that I had Hannah. How many total ways, if all these were distinct, could I arrange these out? 6 factorial, right? 6 times 5 times 4 times 3 times 2 times 1. How many ways could I arrange the H's? 2 factorial. What about the A's? What about the N's? What about the Q's?
0.
So 0 factorial should be equal to 1. Very good. So this would be, I think that's 720 divided by 8, where there'd be 90 different ways to arrange the letters of Hannah. Let's try one more. I'm not sure why. I just want to be a sheet, bab, 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 bab. So how many ways could I arrange these letters? So 5 factorial divided by 1 factorial, 4 factorial, or just 5. You can kind of see that, because where could I put the B? I could put the B first, second, third, fourth, or fifth. So these kind arguments we'll get into, and they're kind of, I think they're rather fun. And we will look at those. Okay, so one hopes that you put your Bluffton project either in the box or you post it on Blackboard by now. For the data Lab 1A or the Lab 1B on Moneyball, you can either post in the box or posted it on Blackboard. Okay? Yes?
Is that by Monday morning or Monday night?
I think I said Monday at 4.
Monday at 4.
I think. Yes, Abby?
For homework 2.1 on Monday, do you want that?
Either way, either scan it and post it on Blackboard for Calvin's sake, or you could turn it in a box, stapled, leave 4 lines between them, right, so we can make comments. And I should have asked if there were any questions on section 2.1, because really you're supposed to do 2.2 over the weekend and ask questions on Monday, so you can turn it on Tuesday. I gotta turn off my video.